Lesson 10-3, Probability with Permutations and Combinations. A permutation is an arrangement of objects in which order is important. One permutation for shuffling the songs on a 7-track playlist would be track 5, track 7, track 1, track 2, track 6, track 4, and track 3. That's one specific order. Using the fundamental counting principle, there are 7 times 6 times 5 times 4 times 3 times 2 times 1, or 5,040 possible playlists. The expression 7 times 6 times 5 times 4 times 3 times 2 times 1, used to calculate the number of permutations of the 7 tracks, can be written as 7 with an exclamation point, which is read as 7 factorial. Factorial just means the factorial of a positive integer n is the product of the positive integers less than or equal to n, and is written as n factorial. So it's always going to be whatever n is times one digit less than that until you get to 1. Anytime you have 0 factorial, that is 1, so that means you have one possible way of getting 0. Suppose you will listen to only 4 of the 7 shuffle tracks. Using the fundamental counting principle, the number of permutations of 4 tracks played from a 7-track playlist is 7 times 6 times 5 times 4, or 840. Another way of describing this situation is that this is the number of permutations of 7 tracks taken 4 at a time. You can use the permutation function, which on your calculator would be NPR. The n being the total number you're looking at, you're only focusing on 4 at a time. So this number can also be computed by using factorials if you wanted to use it that way. So for permutations, the number of permutations n distinct objects taken at a time is denoted by NPR and given by NPR, or if you use the formula, this would be n factorial divided by n minus r factorial. So if I did 7 permutate 4, I would have 7 factorial divided by 7 minus 4 factorial, which, as you can see, still gives you 7 times 6 times 5 times 4, or 840. Probability using permutations. Recall that the probability of an event is the ratio of the number of favorable outcomes to the total number of outcomes. Define probabilities with permutation. The number of favorable outcomes and the number of total outcomes can be written as permutation. So a number of distinguishable permutations of n objects in which one object is repeated are 1 times, another is repeated are 2 times, and so on, is n factorial divided by r1 factorial, r2 factorial, and so on. Another way is just doing 1 over NPR. That will give you the probability of permutation. Actually, for this one, with repetition, you would have to, if there were whoever numbers are repeated. So like say I had 7 factorial. So 7 tracks, but 3 of the tracks repeated. I would just have 3 factorial down here. So our first example. Aisha and Liam sign up for an open mic night with 32 available slots that are filled at random. What is the probability that Taisha will perform first and Liam will perform second? So there's only one way for Taisha to perform first and Liam to perform second. So let's do one outcome. Since order does matter because Taisha has to be first and Liam has to be second, I have 32 slots. And I'm only looking at 2 slots at a time. So this is permutation. So on my calculator, I can do 1 divided by, and then I'll type in 32, hit the math button, go over to PRB for probability, and I want to choose number 2, and then I put a 2 in here, hit enter. I get this really long decimal, put it as fraction though. That would give us 1 out of 992, or if you did it as a percent, multiply that by 100, you would get roughly 0.001. Next question says Miranda, Connor, Roger, and Kate are lining up randomly to take a selfie. What is the probability that Miranda will stand on the far left and Kate will stand on the far right? So we have 1, 2, 3, 4 people. So I have 4 here. They want Miranda to be on the far left and Kate to stand on the far right. It has to be in that particular order here. So there's only one way for that to happen, or order does matter. And I need to have Miranda and Roger in those locations. So that would be 1 out of, I'm only using 4 people per mutate, and I'm only looking at 2 people that have to be in a specific location. I'll grab our calculator here. We have 1 divided by 4, math, PRB, number 2, 2 at a time, hit enter, hit math, enter again. That gives us 1 out of 12. So this will give us 1 out of 12 chances of that happening. Next, 5 geometry students are asked to randomly choose a polygon and describe its properties. What is the probability that the first 3 students choose the hexagon, pentagon, and the triangle in that specific order? So this is permutation. So we're looking at 1, 2, 3, 4, 5 shapes. And we're looking at 3 specific ones at a time. So on our calculator, we would type in 1 divided by 5 math, go to PRB, number 2, 3 at a time, math, enter, so 1 out of 60. So you have 1 out of 60 chances of that happening. Example 2, these are probability with and permutations with no repetition. So for a project, Remy selects 12 family photographs that will randomly play in a slideshow. The slideshow will not show repeat photos. All 12 photos have been shown. 3 photos are of Remy's entire family, 2 photos are of his brother, 3 photos are just of him, and 4 photos are of his sister. What is the probability that the first 4 pictures in the slideshow will be of Remy's sister? So for this one, there are 4 photos of his sister, so I'm going to have 4 factorial on top. And then on the bottom, I'm going to do permutation. So out of all the family pictures, there are 12, which we're only looking at 4 at a time. First, we want to do the denominator part. So if I did 4 permutate, or 12 permutates 4, that gives us 11,880. There's 11,880 choices of possible outcomes there, and then I have 4 factorial on top. So now if I did 4 factorial and the factorial key on your calculator, if we went 4, hit math, go to probability, that's number 4 here. Then divide that by 11,880. And then hit math, enter. Our fraction would be 1 out of 495. So that would be the probability of the first 4 pictures being Ramsey's sister. Next, at the start of each semester, Sarah's dorm assigned 7 sophomore residents as building aides, 1 for each of the day of the week. There are 40 sophomores in Sarah's dorm this semester, including Sarah and her 2 roommates. If the Monday, Tuesday, and Wednesday aides are selected first, what is the probability that Sarah and her roommates will be selected for those days this term? So to find the total possible outcomes, on the bottom I'm going to have, there are 40 sophomores, and I'm only looking at 3 at a time, which would be Sarah and her two roommates. So if I did 4 permutate 3, that gives me 59,280. And in the numerator, I'm looking at how many times or how many different ways can Sarah and her roommates be Monday, Tuesday, and Wednesday. So there are actually 6 ways of that happening. And to doing that, how did I get 6? Because if I did 3 of them have a possibility of being on a Monday, that means there's 2 left for here, there's 1 left here. That will give us a total of 6. I'm just using the factorial, 3 factorial. So when I simplify that, 6 divided by 59,280, that gives me, let's reduce this. If I divide this by 6, I end up with 1 out of 9,880. And that would be the probability that those 3 would be selected first. Next, one game show has contestants arranging 5 number tiles to build their guess at the price of a prize. Mishka is given 5 tiles with numbers 2, 2, 5, 5, 8. Mishka arranges the tiles randomly. What is the probability that she arranges them in the correct price of 25,852? So this one has repetition. So again, I use the formula n factorial divided by r1 factorial, r2 factorial. If I look at the numbers, the r1 and r2 just means the numbers that are repeating. So 5n factorial means we have 5 tiles, so that's 5 factorial. R, I have 2 2's that are repeating, and I have 2 5's that are repeating. So now if I do the math, so that'd be 5 factorial divided by 2 factorial divided by 2 factorial. This will give us 30. It means we have 30 total arrangements, and out of those 30, only one of the choices will have 25,852. So the probability of that happening would be 1 out of 30. Next, Caden is switching to a different cell phone provider and wants to keep the same digits in his current phone number. 2555225. What is the probability that his new number will be 5522552, given his new number has the same digits as his existing number? So there are 7 digits. That'd be 7 factorial. Let me do it as a probability. So there's only one number to be like that. And then on the denominator, to find the total number, possible outcomes, we have 7 factorial divided by 5 is listed 4 times, so that's 4 factorial. 2 is listed 1, 2, 3 times, so that's 3 factorial. So let's do the denominator first. So we have 7 factorial divided by 4 factorial divided by 3 factorial. And we get a total of 35 down here. So there's 35 different phone numbers. Out of the 35, only one of them will have that number. Moving on to another one. Championships, if you place the following trophies on a shelf in random order, what is the probability that they are in chronological order by year? So we have 1, 2, 3, 4, 5, 6, 7, 8 trophies. That'd be 8 factorial, and any of them repeat in years. We got 1, 2, 3 in 2017. Then we have 2019 is repeated 1, 2, 3 times. That's it. And then there's only one way to put them in that order. So 8 factorial divided by 3 factorial divided by 3 factorial is 1,120. There's only one way to put it in the exact order here. So you would have 1 out of 1,120. Next is probability using combination, where order does not matter. Combination is a selection of objects in which order is not important. A combination of n objects taken r at a time, or NCR, is calculated by dividing the number of permutations, NCR, by the number of arrangements containing the same elements, r factorial. So you can see the formula down here for combination. You also have that same function in your calculator, same place where you found the permutation. Now the difference here is you're going to see that we have to take out an r factorial a second time, because since order doesn't matter, if I have x, y, z, that's going to be the same as y, x, z. The order doesn't matter, they're still the same. So that's why we have to take out the r factorial again. Recall that probability of an event is the ratio of number of favorable outcomes to the number of total outcomes. So to find the probabilities with combinations, the number of favorable outcomes and the number of total outcomes can be written as a combination. Our example here. If 3 points are randomly chosen from those named on pentagon ACEGJ, what is the probability that they all lie on the same line segment? For this one, we need to find the total. So for the total, we have 10 letters or 10 points. Combination order does not matter. And we're only looking at 3 at a time. And the numerator, they have to be all in a straight line. So we have a straight line here. That's 1, 2, 3, 4, 5. So we have 5 in the numerator. So now if we did the math, we would do 10. Grab our calculator. We type in 10, hit math, go to PRB. Now we're going to choose the NCR, 3 at a time. That gives us 120. And in the numerator, we have 5. So then we do 5 divided by 120. Change that to a fraction. And that gives us 1 out of 24 chances of that happening. Next, a bag contains 6 blue marbles and 9 orange marbles. Alex randomly removes some marbles from the bag. Find the following probabilities. What is the probability that Alex removes 2 orange marbles? So for this one, removing orange marbles, we're going to do combination on the top divided by the combination on the bottom. And the combination on the top is the favorable, and the bottom is our total. So in the favorable, we have 15 total marbles, and we're looking at orange, 9. And in the bottom, we have 15, but we're looking at only 2 of them, choosing 2 of them. So on our, actually, up on top of favorable, there are 9 total orange ones. We're only looking at 2. Now with our calculator, we would have parentheses 9, choose 2. Then we're going to divide that by 15 total. Math, choose 2 at a time. So if we hit the math, change that to a fraction, gives us 12 out of 35. Or if you put it as a percent, that would be 34.3%. Next part is what is the probability he removes 3 orange marbles. So favorable are the 9 marbles, 9 orange ones. He is removing 3. And on the bottom is the total, which he only has a total of 15 marbles, but he's only removing 3 out of them. So if I do the probability of that, we do second choose or second enter, change our numbers from a 2 to a 3. Then hit math. So that'll be 12 out of 65. Or if you put it as a percent, that would be 18.5%. And our last question, a lattice is a point at the intersection of 2 or more grid lines in a coordinate plane. If 2 lattice points are chosen randomly in rectangle ABCD, including its sides, the probability that they are in rectangle WXYZ includes its side is blank. And if 4 lattice points are chosen randomly in rectangle ABCD, including its sides, probability that they are W, X, Y, and Z is blank. So we need to find the probability of each one of those. For this first one, we're looking at it has to be inside the smaller triangle. So there's 16 lattice points. Lattice points means these corners here. So there are 16 on the inside. So we have 16. We're only choosing 2. And then out of all of them, there are 36 lattice points. If you include all these other ones on the outside plus the ones on the inside. And we're going to still choose 2. And when we do that, we end up with getting an answer of 4 out of 21. This is 4 out of 21, or if you did it as a percent, that would be about 19%. Now, if you're doing 4 lattice points, that would be 16 choose 4 divided by 36 choose 4. For our calculator, we have 16 choose 4 divided by 36 choose 4. This one, we would have to do slightly different here because it has to land in the purple or in the purple, but it has to be also in the yellow. So there was, if I did 36 choose 4, that would give us 58,905. So there's 58,905 possibility of getting 4 in the yellow. There was only 1 that gets W, X, Y, and Z on the inside. So our probability would be 1 out of 58,905. As our lesson on probability with permutations and